All right, this is going to be 1.10 of our coordinate geometry unit, and we're going to talk about transformations. So what is a transformation? A transformation is when a geometric figure changes in position, shape, or size. So we have your basic transformations here. So if you look at the red and the green puzzle piece, it looks like the red puzzle piece is flipping over, okay? In this case, also kind of like reflecting. So if I draw a line right here down the middle, if I can draw it straight, that would be like a line of reflection, okay? Better something like this. Right down the middle right there, okay? So reflecting over that line, that green line, okay? This one here looks like it's just simply sliding to the right and then up, okay? So that's like translating. This puzzle piece looks like it's turning about a point, maybe about right there. So this is the center of rotation. And then this last one obviously is changing in size. So it went from small to big if you're looking at it like that. If you're looking at it this way, it's shrinking in size, okay? An isometry is a rigid transformation in which a transformation takes place and the pre-image and the image are going to be congruent, okay? So for instance, this one here looks like an isometry, this one and this one. This one right here would not be an isometry because these are not congruent. One is small, one is big, okay? All right, some notations you'll need to make note of when we do this is when a transformation maps a figure onto its image and is described by an arrow notation, then we have a transformation going on, okay? So we're mapping a figure, arrow notation. Prime notation is an apostrophe right here. This is an apostrophe, which you'll notice is right here. You see that apostrophe, this apostrophe. So that's J prime, K prime, Q prime, okay? So you use the word prime. And that's used to identify the image points, okay? The image points, so that's the image. So speaking of image, we're gonna call this one here. This one would be the pre-image. And this one is the image because it has the prime, okay? And so in this case, figure K prime is the image of K, okay? So that's what we just labeled. So triangle JKQ maps onto triangle J prime, K prime, Q prime. All right, so get used to this notation so that way you can tell which one's the pre-image and which one's the image. All right, let's start with the easiest transformation of all, and that is translation. So a translation is an isometry that slides a figure along a straight line path, moving each point the same distance in the same direction. So for instance, this one here looks like this is the pre-image, so that might be a good thing to label. So that one's your pre-image, and this one's your image because of all the primes. So it looks like it went that way and down. So you got to be real specific. So I always like to pick a point and go from there. So let's pick point B. So B is here and B prime is here. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. And then count down. It goes 1, 2, 3. 3 units down, okay? So it slid 9 units to the right and 3 units down. So in the right, going to the right, that way, that is your positive direction. Going down, that is your negative direction. So if I'm going in the positive direction, I need to add 9 to coordinate B to get to B prime. And then I need to minus 3, go down to coordinate B to get to B prime. So here's what this rule would look like. X plus 9, comma, y minus 3. So I want you to be able to write the rule for any type of translation, okay? And this one's pretty easy. So whenever I slide to the right, I'm going to add to the x variable, and then I'm going to minus to the y because I'm going down in the vertical direction. All right, let's go to the next one. Let's try this one. It says, write a rule to describe this translation. All right, so always think about where's your pre-image. So this one's my pre-image. This one down here is my image. So it looks like it goes to the left a little bit and then down a bunch. So pick a point. Let's count it out. Let's do Q. Here's Q and here's Q prime. So I always like to connect them. Okay, so this one goes 2 to the left. So if I'm going left, that means I'm going to minus 2. Okay, now how many down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I go down 11, I'm going to minus 11. And that's it. There's your rule for translation. You can always double check with the coordinate too. Okay, so 2 is for R. This one right here. R is at 2, 2. And then R prime is at 1, 2, 3, 4, -4, and -9. So think about that for a second. How do we get from 2 to -4? Okay, I'm sorry, -2. How do we get from -2 to -4? Well, we minus 2, which is what we wrote on the rule. How do we get from +2 to -9? We're going to minus 11, which is what we wrote in the rule. So +2 to -9. There you go. All right, that's translation. Let's go to a tough one. Tough one is rotations, okay? This is in isometry again, because this figures stay the exact same size. And the figure is obviously being rotated a certain amount of degrees about a point onto its image. Rotations are going to be counterclockwise unless stated otherwise. So we're always going to go counterclockwise direction. So here, what this shows, it shows a 90-degree rotation. And the way you know it's 90 degrees, because if you focus on point A, which I drew the dotted green line to the center, this is the center of rotation. The coordinate 0, 0, which is the origin, that's always going to be your center of rotation, okay, mostly. And then it goes to A prime over here. So when you see these dotted lines, that makes a perfect right angle. How do you know it's going to be a right angle? Because of the slope here. So this slope for this green line is down 1, 2, 3, 4, 6. Okay, so it goes down 6 over 4. So the slope of this line is -6 over 4. Now look at the slope of this line. This slope goes over 6 down 4. Okay, and so this has a positive slope of 4 over 6. Do you see how they're opposite reciprocals? And so you just learned that opposite reciprocal slopes have are perpendicular lines. Okay, so that's how you know it's a perfect perpendicular. So now the question is what is the rule? So let's focus on point A. Point A is at 6, 4. And then A prime, the image, is at -4, 6. So look to see what's happening here. They look almost identical. Let's try one more. Let's look at letter C. Letter C is at 8, 1. C prime is at -1, 8. So look what's happening here. At my highlighter. This 6 now went over here into that position. Look at the 8. The 8 went over into that position. So if you think about it, the x variable now became the y variable. So they're switching places. Now look at this one. This 4 moved to this spot, but it became what? Negative. So the sign changed. This one switched over to this spot, but it also changed the sign. So what are we going to do? We're going to switch the y and the x, but we're going to change the sign on the left side over here. So that is your rule always and forever for a 90-degree rotation. So I'm going to highlight that, and it's for 90 degrees counterclockwise. Okay, so you need to work this out. So let me show you how to work out the next one. So the next one, it says rotate this image 180 degrees. Okay, so pre-image, of course, this is the pre-image. So what am I going to do? I'm going to take a dotted green line. Okay, it doesn't have to be green, but I'm going to connect A to the center. Okay, and then you got to think about the slope here. So the slope, or think about just 180 in general. 180 degrees is going to end up like this, okay? Either direction or like this, all right? So that's your 180-degree turn. So I want to have another flat line kind of going like that, okay? But I want to focus on the slope and make sure I keep it the same. So the slope of this dotted green line is up 4/6. So guess what I'm going to do? I'm going to go over 6, 1, 2, 3, 4, 5, 6, and then I'm going to go down 4 right there. And so if you look at this dotted line and I keep it going down 4/6, isn't that a 180-degree turn going from here to here about to the origin? That's 180 degrees. So this right here is going to be your A prime. And watch this, we'll be able to figure out our rule pretty quickly. So we're going to go A, B, C. A is at 6,4. B is at 3, -3. And C is at 8,2. Now, we already know A prime where that's going to be. That's going to be at -6, -4. So ask yourself, let me get my highlighter, it went from 6,4 to -6, -4. That's a pretty easy switch. You just change the sign. So your rule is going to be x comma y maps onto -x, -y. Okay, so now let's apply that to the B prime and the C prime, and then we'll be able to graph our new image. So B will be at, this was positive, so we're going to change that to negative, and then that's negative, so we're going to switch that to positive. These two are both positive, so they're going to change the sign on both of them to like that. So let's graph it over here. B prime is going to be at -3, 1, 2, 3, +3. So right there, there's your B prime. And then C prime is at -8, -2. There we are, and that's C prime. So now when I connect the dots, let's use blue. So I connect there to there, there to there, and there to there. And then it should look exactly like the rotation. Okay, let me make sure I graphed all of them right. 1, 2, 3, 4, 6, 1, 2, 3, 4. Yep. And there we go. A little bit smaller. I just need to draw my lines a little bit better. All right, and there it is. That's what 180-degree rotation looks like. Okay. All right, let's go to the last type of rotation. We're only going to do 3 types: 90, 180, and now 270. Okay. So 270 degrees is a long way. Let's think about what we just did. We just did 90, which ends up about right there. Then we did another 90, 180, so we ended up on the opposite side. So think about it, 270 is going to end up over here. The best way to think of that also is it would be 90 degrees in the clockwise rotation. Okay, so I always like to think of that way. So then I can make my dotted line here. Let's go green again. And let's put it from here to the origin. Now, I want to make a 90-degree angle, so I'm going to do the opposite reciprocal slope. So think about it, it's going to be something like this over here. That's too acute, that's too obtuse. So it's going to be somewhere over here like so. Okay, so I'm just going to put a random line like this. And then now watch, I have to figure out the slope. So the slope is up 4 over 6. Up 4 over 6. That's a positive slope. Well, in order to get a right angle, I have to do the opposite reciprocal of that. So opposite reciprocal is -6 over 4. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Ooh, look at that. I was a good estimator right there. So that right there, I know for sure makes a perfect right angle when I use the slope correctly. Down 6 over 4. So this is going to be my A prime. So let's write it down and figure out what all you need to do that is do this once. So A is at 6, 4, and it's going to be mapped onto A prime, which I figured out by doing the opposite reciprocal slopes, and that's at 4, -6. So you can see the pattern there with this case. Notice they switched, okay? So let me get my highlighter and emphasize that. The 6 now went to the other coordinate spot, but the sign changed. The 4, which was in the Y spot, now went to the X value spot. So what's happening here? They're switching and the sign is changing on only one of them. So here's how this is going to look. This is going to be the Y came here. Notice, look at that, the blue and the blue. And then the X switched over here, except it didn't stay a +6, so I got to change the sign. And there's your rule. So now let's apply that rule to the other two coordinates, and then we'll graph. We don't need to do that 90-degree angle every single time. It's easier just to apply the rule to B and C, and then see what they change to. So B is at 3, -3. C is at 8, 1. You know what? I just realized that. I think I did that wrong. There it is. This C was at 8, 1, not 2. Good thing I caught my mistake. I knew it looked kind of weird. So this should be a 1, which makes this also -1. So let's fix that. The good thing I noticed that because I'm using the same triangle. So this should be here. That should be there. C should be there. There we go. That looks a little bit better. It looked a little odd at first. So I would have gotten that one little point wrong if I did this one on my homework like that. Okay, anyways, back to over here. So now let's use this rule to change these points so we can figure out where our new triangle is going to be. So we are going to switch them. So this Y switches to the front. Let's go ahead and take care of this one, C prime. This Y, which is a 1, switches to the front. Okay. Now the X, it switches, but we got to change the sign. So the X over here is a 3, but we don't want to keep it the same sign. We want to change the sign. This X is an 8. We don't want to keep it a +8. We want to change the sign. All right, so there's our new coordinates. Let's finish off this triangle. So B prime is at -3. 1, 2, 3, down 3. So there's B prime. And then C prime is at 1, -8. So down, 1 to the right, down 8. Here we are. There's. All right, now let's connect them. So we'll connect, let's use, so connect there to there, there to there, and there to there. Okay. And you can leave the right angle there, or you can erase it if you want, but that's what a 90-degree clockwise or 270 degree turn looks like coming around like that. Okay. All right, so those are your rules. You do have to get used to using those. Okay, those are not in the formula chart. All right, next type of transformation is a reflection. This is an isometry that flips across a line, creating a mirror image. So here's the pre-image. And then here's the image over here based on the prime notation. Okay, the way I like to see it, the red line is your line of reflection. The C is here. Notice it's 3 units away. Well, guess what? It's going to be 3 units away in the opposite direction. That's it. Okay, so let's check it out. C was at 1, 2, 3, -3, +4. That's your C. And then C prime ends up being at 3, 4. So the only thing that changed there was the sign on your X coordinate. So guess what? That's as simple as what your rule is going to look like. Okay, so this is a reflection over the Y axis, okay, over that vertical line. So pretty easy. That one's not bad. This one here, okay. This one, let's make it a little bit difficult. But by the way, if you were to reflect it over the x-axis, okay, right here, well, now this, it looks like a flag, would end up on the bottom and this would end up on the top, okay? So I'll let you kind of elaborate on that on the homework, but let's go to something more difficult. What about reflecting over the line y equals x? So you got to remember algebra, of course. What does the line y equals x look like? It would look, let's use red. It would look something like this. Okay, it would go through the origin and it has a slope of 1. It has a slope of 1 right there. Okay, so reflecting over it, that means this is going to reflect over the red line somewhere over here. Well, think about, you want to count in the opposite direction like this every time. So look, it goes over 1 diagonal, 2. So I'm going to go 1, 2 diagonals. So guess what? R prime is going to be right there. Okay, let's try that for S. This one's further away. 1, 2, 3 diagonals, 4 diagonals, and a half. See that little half? Half. 1, 2, 3, 4. So this right here is your S prime. Okay, so I'm going to connect those two. A lot of y'all, I bet, didn't think would assume that it would be vertical. A lot of students think it turns out to be different, but look at the opposite. That's how you would reflect it. So let's take a look at the rule and let's just figure out the rule now. So R was at -2, +2. R prime is at 2, -2. Okay, so I can't really tell whenever you have the absolute values of the same exact X and Y coordinate, it's hard to tell if they're switching or the signs are changing. So let's check out S. This one will look better. S is at -7, 2, and S prime, which I already graphed, is at 2, -7. So what happened here? It looks like all they did was switch places. No signs changed. You see that? So they just switch places. So that takes me directly to my rule. My rule is just switch the places. It's going to now be YX. Okay, so let's do that for Q so we can graph it. Q, and let's do that for P. So Q is at -3, 1, 2, 3, 4, 5, 6. Q is at -3, +6. P is at 4, 5, 6. 1, 2, 3, 4, 5, 6. P is at -6, +6. So let's write down its new image point. Q prime is going to be at, just switch spots, 6, -3. P prime is going to be at 6, -6. All I did was switch places. All right, here we go. So 6, -3, 1, 2, 3, 4, 5, 6. 1, 2, 3. That is your Q. And then 6, negative 6, 3, 4, 5, 6. That is, so now draw it out. There it is. Okay, I know it doesn't look like what a lot of y'all thought it would be, but that's how you start off. You always go directly perpendicular, count how far away it is from the line, and keep going in that same opposite direction the same amount of times, okay? Think perpendicular every time like that, just like this one. Look, this one was perpendicular like that. Okay, let's do one more. This one's a little trickier. This one says, graph the image that would reflect over the line y equals 2. So you got to remember some more algebra. The line y equals 2. The line y equals 2 is actually a horizontal line, okay? So y equals 2. This is the line right here in red. That's what you want to reflect over. So guess what? I'm going to count the opposite direction. So x is 1, 2, 3 units away. I'm going to go 1, 2, 3 units away. So there's my x prime. Y is 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units away from the line of reflection. So I'm going to go 8 units away here, which is right there. So there's y prime. Z is on the same line, so I know it's going to be like that. So here is the reflection of that. So graphing it is easy. Finding the rule is a lot more challenging. So we need to write down all 3 letters and really investigate and see what's happening here. So x is at 2, negative 1. Y is at 1, 2, 3, 4. 2, 3, 4, 5, 6. 4, negative 6. And then z is at 10, negative 6. Okay, so now let's see what image points ended up at and see if we can discover the rule. So we got to study these points. So x is now at 2, comma 1, 2, 3, 4, 5. 2, comma 5. Y prime is at 4, comma 10. Z prime is at 10, comma 10. Well, one part of the rules is super easy. The one that stayed exactly the same. And that is the first one, right? Didn't the x's stay exactly the same? So the hard part is what's happening as we go from here to here. From here to here. And obviously this one's the same. Here to here. Well, obviously the sign change. And whenever you do reflection, guys, the sign's going to change whenever we reflect over a horizontal line. So the sign changed. So I want to put a sign change on that so far, but it didn't just change. So let's focus on that. Well, the sign change to negative 1 would be a positive 1. Well, that's not a 1. This sign change would be a positive 6. Well, that's not a 6. But check it out. How is this number 1 related to the 5? How is the 6 related to the 10? They're 4 units away. So think about that. You're just going to add 4. So believe it or not, this is kind of like a double transformation here. Okay, so we're going to add 4. That's it. Okay, so this is kind of like a composite transformation where you've reflected over the x-axis and you move up 4. Okay, now let me give you a quick hint on what to do on this. Let me get my highlighter. Anytime you reflect over the line y equals 2, all you had to do was double the 2, and then that would be positive 4. Okay, I don't like that color. Let me get a different color. Try. So if that's a positive 2, you just double it, and that's going to be 2, or 2 times 2 is 4. But you have to remember to change the sign on your own whenever you reflect. Okay, so remember that. Okay, maybe write a little side note here. Double the 2 to get 4. Okay, all right, so remember that for your homework. Okay, and we're going to skip that one. Okay, and let's do a dilation. Last one. A dilation is a non-isometry because it changes the size of the geometric figure, but it doesn't change the shape, okay? So when a figure enlarges, the rule will include a number greater than 1. When a figure reduces in size, the rule will include a number less than 1. So for instance, let's take a look at this coordinate here. What's happening here? It's getting what? Bigger. Let's write that down, okay? Because this one is the image over here. And this one down here is your pre-image. So as we've been doing, let's study some of these coordinates. So A is at 1, 3. A prime is now at 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 9. So study those numbers a little bit. Let's do one more and you'll get it really quick. B is at 1, 1. B prime is at 3, 3. So the question is what do you do to the pre-image points right here to get these here? So look, it went from a 1 to a 3. Okay. It went from a 3 to a 9. Some of you probably already figured out, oh, it tripled in size. So look how your rule is going to look. 3x, 3y, because all you got to do is multiply these by 3. Okay, that's it. That's for dilations. One more dilation and then that's it. So it says graph the image of a triangle ABC with a dilation of being 4 times smaller. Think about that, 4 times smaller. So let's write the first coordinate down. Always work with the coordinates. Okay, let's start with C. C is at 10, 8. How do I get 4 times smaller? Okay, 4 times smaller. That one may be kind of tough. Let's try another one. Let's try number or letter A. A is at 1, 2, 3, -4, 10. And then B is at -10, -4. Okay, so to get 4 times smaller is kind of like dividing by 4 or multiplying by 1/4. So there's 2 ways to do that. Well, 1/4 of 10, okay, or 10 divided by 4 is what you want to do to figure out your first coordinate for C prime. So 10 divided by 4, I believe, is 2.5. This one's actually pretty easy. 8 divided by 4 is 2. So there's your C prime. Okay, this one might be pretty easy because we already did the 10. Well, what's -4 divided by 4? That would be -1. And then we already did the 10, so that is your 2.5. There's that 10 again. So B prime -10 divided by 4 is -2.5. And then there's -4, so that'll be -1. So there's our new coordinate. So let's graph it and see how it ends up. So 2.52, 1, 2, 2.5, 1, 2, right there. That's going to be my C. Oh, wait, I did something wrong. C is not at 10, 8. C is at 10, -8. That should be a negative. Okay, some of you are probably listening to me saying she is wrong. You are right. Okay, so that should be a -8. So let's try that again. Okay, 2.5, 1, 2.5, and then down 2. So you see how it's right in the middle? You can handle 2.5. So that's going to be your C prime. All right, let's do A. A is at -1, 2.5. So -1, 1, 2.5. There's your A prime. And the last one, -2.5, 1, 2.5, down 1. That's B prime. That one should be right down the middle. Now just connect them. So connect there to there, there to there, and there to there. So that blue triangle got 4 times smaller. So there's a couple of ways you can write this rule. You can write it either like this, x over 4, because we divided by 4, or some people will write it like this, 1/4 times x, comma, 1/4 times x. Both of those mean the exact same thing. And that is all your transformation notes.